So the today's topic is the transmission media. Let's start with this. Okay, so first we have to come on this point that what is transmission media? In data communication technology, a transmission medium is a physical path between the transmitter and the receiver. That is, it is a channel through which the data is sent from one place to the another. Transmission media is broadly classified into the following types. It has we can categorize it into the two categories: the guided and the unguided. So, what is transmission media? Basically, whenever the two systems they want to communicate with each other, whenever the systems communicate with each other, they send some messages, they pass some data, they send some data, they receive some data, and now they use some type of medium to send that data, and that particular medium is known as the transmission medium, from where the data is traveled from the sender side to the receiver side. Now we have two different types of transmission media. Either the first one is the guided, or you can say the wired transmission media, and the second one is the unguided. And unguided, you can say that it is wireless transmission media. So the best example of the wired transmission media is whenever you are working in the computer labs, and these labs are in the networking form. So these systems can be connected with each other with the help of wires. So this is called the transmission media, the guided transmission media. And in the case of unguided transmission media, the best example is your cell phones. The no wire is directly connected with your cell phone, but still you are able to receive the internet signals on that. Now you can receive the signals from the air. Your system receives the signal directly from the towers. So this is the example of unguided media. Let's start discussing the first, that is guided media. It is also referred to as the wired or the bounded transmission media. Signals being transmitted are directed and confined in a narrow path by using the physical link. What is why it is called a bounded or the guided media? Because whenever we send some data, the data is guided by the sender to follow the specified path, because a link is established between the sender and the receiver through a wires, and all the data that can be traveled in between these two systems, they can follow the particular path. I just give you the simple example. Suppose you see the fans that are available in your homes. You simply switch on, you simply on the switch, and the fan will start moving. What will happen whenever you switch on? Whenever you on the switch, a current is passed and that traveled through the wire that is connected one side with that switch and other side with that fan. So what it means, now the signals can travel through the switch to the fan. They are traveled through that particular path, they are traveled through that particular wire. That's why it is called the guided media. Now compare it with the unguided media. You can see the number of ads on the televisions. Right now we have an option of wireless fans. What it means, you simply click on the remote and the fan will automatically start. What will happen? The fan will automatically start when we click on the power button on the remote. But it is unguided media, so there is no confined path is established between the remote and the fan. Now the data or the signals can travel from the remote to the fan through the air. They can follow any path. They can travel either through goes to the right side, then goes to the fan. Either they go to the left side, then goes to the fan. What it means, no wire is there, no direct dedicated link is there. Only the data can be traveled or the signals can be traveled in the form of light, and that process through the air. So this is the difference between the guided and the unguided. Clear? Now we are discussing the guided media. Now we have the different features of guided media. The first, high speed. The speed is very high. How the speed is high? Because we have a dedicated link from the sender to the receiver. whenever we send the data or whenever we send some signals from sender to receiver, they can also follow the specified path. The path is defined. No need of discussing the path. The packets, they only travel through the confined path. So automatically the speed is high because the path is established at the starting point and all the packets, they are going to follow the same path. Next, secure. Why the packets or the data is secure whenever when we are using the guided media? Why they are secure? Secure because the all the packets, they follow the same path, or all the packets, they follow the dedicated path. None other of the any packet can follow that particular path because a dedicated link is made between the sender and the receiver. Only the packets that sends from that particular sender or the path that is defined in the header of the packet, only these packets can follow that particular path. So there is less chances of overlapping, less chances of packet loss. That's why the data is secure in the case of guided media. The third is used for comparatively shorter distances. Now we are using the guided media normally when the distance is short. Distance is short means normally we can use it into the local area networks. Why? Because whenever we are moving to the larger distance, if we are using the guided media, we require a large number of wires there, and it's very difficult to maintain all the wires in a bigger area. So that's why whenever we are restricted to some physical area, then we go with the guided media, or you can simply say that in the local area networks, normally we go with the guided media. So this is all about the guided media and the features of guided media. Now let's move further. Now we are now discussing the guided medias. The first one is the twisted pair cable. It consists of the two separately insulated conductor wires wound about each other. Generally, several such pairs are bundled together in a protective sheet. They are the most widely used transmission media. Further, the twisted pair is also is of two types. Now, what is twisted pair? As the name implies, twisted. And here we have the two wires that are twisted with each other, that are overlapping with each other, and they are normally bundled together in a protective sheet, and they are using to send the data or send the signals from the sender side to the receiver side. So just wait for a minute. Yes, so this is all about the twisted pair cable. Okay, now we are discussing the two types of twisted pair cable. The first is unshielded twisted pair cable. Unshielded means no shield is provided over there. This type of cable has the ability to block interference and does not depend upon a physical shield for this purpose. It is used for telephonic applications. Now you can see the diagram. The twisted pair cables are there. In the every cable, it is a combination of two cables that are twisted with each other. And the first form is unshielded. Unshielded means there is no shield is given over the wires. Basically the shield is used to protect the wires from the external noise, and these type of wires can normally be used in the telephonic applications. Whenever we are using the telephonic applications, or whenever the establishment of telephone networks are there, they can use the unshielded twisted pair. Second, now the advantage of unshielded pair. The first is least expensive. Why the least expensive is there? Because it is unshielded. No extra covering is there. If the no extra covering is there, automatically the cost of the wire is less. Second, easy to install. Now look at the diagram. They have the simple, we have the simple, the combination of two wires, and it's easy to install means we simply connect these wires with the other wires. The third, high speed capacitor. The speed capacity is higher in the case of unshielded twisted pair. Next, susceptible to external interface. Yes, susceptible to the external interface means they are susceptible to the external noise. Why susceptible? Because the no extra covering is there. If the extra covering is there, then that particular covering is going to protect it from the external noise. Next, lower capacity and performance in comparison to STP. STP is shielded twisted pair. It is the capacity of the unshielded pair is less than whenever we are comparing it with to the shielded twisted pair. And the performance is also lower as compared to the shielded twisted pair. And the last one is short distance transmission due to attenuation. Due to attenuation, we are using these type of wires into the short distance transmission. Attenuation means the external noise. If the external noise is mixed with the your signals will be altered, and you cannot receive the same signals as the same signals sent by the sender. So these are the advantages of the unshielded twisted pair. Now let's move to the shielded twisted pair. First, you can simply look at the diagram. These are the twisted pair cables. Look at on your screens. They are the same. Only that particular silver covering is there. That is not present in the case of unshielded pair. This is the difference. This type of the cable consists of the special jacket to block the external interference, and this silver one is called the jacket or covering, you can say. And what is the purpose of this jacket? To block the external interference, to block the attenuation, to block the external noise. It prevent this particular jacket can prevent these twisted pair cables from the external noise. If the external noise is not mixed with these wires, automatically signals remains the same. It is used in fast data rate Ethernet and in voice and data channels of telephone lines. Where it used whenever we are using the fast data rate in the Ethernet, whenever we are using the internet into the local area networks, where we send the data in the form of voice and the data channels of telephone lines. Telephone line means whenever we are using the internet services through a telephone lines, then we are using the shielded twisted pair. This is all about the shielded twisted pair cable. Now, next we have the advantages of STP, that is called the shielded twisted pair. First, better performance at a higher data rate in comparison to unshielded twisted pair. Automatically, the performance is better. Why? Because extra covering is there. Whenever the extra covering is there, less chances of attenuation, less chances of mixing the external signals. Automatically, the performance will be okay as compared to the unshielded pair. Eliminates crosstalk. What is crosstalk? Crosstalk means whenever the external signals can overlap with your internal signals. So automatically your signals will alter and you cannot receive the same signals. It eliminates the crosstalk. How? Because the extra covering is there. Whenever an extra wire that is overlap with that particular wire, first it covered with the wire, not direct link with the twisted pair cables. Third, comparatively faster. It is faster as compared to the unshielded twisted pair cable. Comparatively difficult to install and manufacture. Manufacturing is difficult as compared to the STP. Why? Because they required extra shielding over there. And difficult to install because whenever we are going to install these wires, we also take care of that extra jacket or extra covering. More expensive. Why the more expensive? Because the extra covering is there and we have to pay for that extra covering. The last one is bulky. It is bulky in size because the extra covering is there. They can use some space. So automatically the shielded twisted pair cable is bulky as compared to the unshielded twisted pair. So this is all about the twisted pair cable. Okay. Now the next is coaxial cable. We can also call it the cox cable or the coaxial cable. It has an the outer plastic covering containing the two parallel conductors each having a separate insulated protection cover. The coaxial cable transmits information in two modes. It has the two modes, baseband and broadband. First is baseband mode and the second one is broadband mode. Cable TVs and analog television networks widely use the coaxial cable. Now, look at the diagram. This is all about the coaxial cable, and where we use the coaxial cable. Normally, we are using cable TVs and analog television networks. Every television network that uses the analog signals, there we are using the coaxial cable. Also, we can say the cox. It is also said that it is a cox cable or the coaxial cable. And now it can sense the data, or the transmission mode is divided into the two parts. First is baseband, where you can say the dedicated cable bandwidth. What it means? Baseband means a dedicated link is created between the sender and the receiver. We have the dedicated link between the sender and the receiver. Whenever we want to send the data, only the dedicated link is used, and the data can be traveled only in between the sender and the user. This is called the baseband mode. And the second one is broadband mode, which means the cable bandwidth is split into the separate ranges. We can split the bandwidth into the separate ranges. If we split the bandwidth, what it means, now we are sending the data to more than one systems. As the name implies, the broadband means one sender, multiple receivers. We can send the data to more than one system in the case of broadband. So this is the difference between the baseband and the broadband. So this is all about the coaxial cable. This is a coaxial cable. It uses the two transmission modes, the baseband and the broadband. Now look at the diagram. Now we are discussing the figure of the coaxial cable. Look at here. This is the main part. Look at on your screens. Who is responsible for sending the data? The metal insulator core. It is called the metal insulator core. Normally it is a copper wire is there which can send the data, and this is covered by the electric flexible tube, or you can say the plastic covering is there. And again, on the plastic covering, the metal insulator is there, or you can say the mesh is there. And at the last point, they have the outer jacket. Outer jacket normally is of black color, and it is made up of the plastic. Now compare this cable with your cable TV cable. We have the copper wire is there, which is copper wire. Look at the first, that is metal, is a copper wire. That copper wire is covered by the plastic covering that is transparent. This is the second one. Then the mesh is there, the silver mesh is there. This is the third part. And at the fourth part, we have a brown covering is there, or which we can say the jacket or the covering. So this is the diagram of the coaxial cable. This is all about the coaxial cable. Now we have some advantages and disadvantages of coaxial cable. Let's start discussing the advantages. The first is high bandwidth. How the bandwidth is high? Because the copper wire is covered by the two other outer jackets. One is the mesh and one is the outer jacket. So automatically bandwidth is not disturbed by the external signals. So the bandwidth is high. Second, better noise immunity. Whenever your copper wire, look at the diagram, this copper wire is covered by these three wires. Automatically it is less susceptible to the noise. If it is less susceptible to the noise, so it has the better noise immunity. The immunity is strong as compared to the noise. The third, easy to install and expand. It is easy to install and expand. Expand means whenever we want to expand the wire, simply we can choose the another wire and connect the copper wire with the copper wire and mesh with the mesh and cover it with the outer jacket. That's why it is easy to install and expand. Next, inexpensive. It is not very much expensive as compared to the other wires. They are not that much expensive. Clear? So these are the advantages. Now the disadvantage, it has the single disadvantage, that is single cable failure can disrupt the entire network. How it is possible? Because whenever there is a single failure, they can disturb all the network. Why they can disturb all the network? Because the data can travel through that particular wire. If the wire is disturbed in between any the path, the complete, it can disturb the complete network or the entire network. So this is all about the coaxial cable or the cox cable. These are the advantages and disadvantages. Then we come into the last cable, that is called the optical fiber cable. It uses the concept of reflection of light through a core made up of the glass or plastic. The core is surrounded by a less dense glass or the plastic covering called the cladding. It is used for the transmission of large volume of data. The cable can be unidirectional or bidirectional. The wavelength division multiplexer supports the two modes. Normally they named as unidirectional and the bidirectional. Now look at the diagram. In the case of optical fiber cable, the signals can be traveled in the form of light. Now we are discussing the cable. It is the first part is the core part. It is made up of the glass or the plastic from where the light can be passes in the form of signals. This is covered by the cladding, and that cladding is covered by the coating. And that why we use that cladding and coating, because whenever the data can be traveled in the form of light, the light can be propagated from that particular plastic or the glass coat. To prevent that reflection, we required extra coating is there. That's why the coating is there, which can maintain the signals to remain into the core. And after that, that is also covered by the strengthened member. That strength member means the extra covering is there, which is used to prevent the external noise, or which is used to prevent the external attenuation that cannot be mixed with these signals. And at the end, we have the outer jacket. That outer jacket is used to prevent that particular wire from the physical damage. No physical damage is there if the outer jacket is there. No propagation or the reflection of the light is there, because the cladding and coating is present over there. So this is the diagram of the optical fiber. And right now we are using the optical fiber cable. We all know the fastest movement is of light. When a light movement is very fast as compared to the any signal areas. So whenever we are using the optical fiber, what it means, we are using to transmit our signals, we are using the light. The signals can be traveled in the form of light in the case of optical fiber. Now next we have the advantages and disadvantages. First, advantages are increased capacity and bandwidth. Automatically the capacity and the bandwidth of the light is high, so automatically the optical fiber is high. Lightweight, because no copper wires are using, no copper is there, no iron is there. We are sending the signals in the form of light. Less signal attenuation, because we have the coating, we have the cladding, and we have the outer jacket, so less signal attenuations are there. Immunity to electromagnetic interference. They are immune to electromagnetic interference because it also uses the electromagnetic signals. We are using the light signals, so they can easily mix with the electromagnetic interference. But we have the outer jacket, we have the cladding, we have the covering, so it remains as it is. Resistance to corrosive material. It has the resistance to the corrosive material. Why? Because the light can easily reflect any simple area of glass or plastic. And in the look at the diagram, and the core, that core part is made up of the glass or the plastic, so that's why they are resistant to the corrosive material. So these are the advantages of the optical fiber. Now we have some disadvantages there. The first disadvantage is difficult to install and maintain. Maintenance is very difficult because we are using the light signals. We are using the light to travel our signals. That's why it is difficult to install and maintain. Second, high cost. We are using the light signals, we are using the different wire, so the cost of this wire is always high as compared to the other ones. Fragile means whenever we have any disturbance or the physical damage is there, it's very difficult to maintain that physical damage. We required external connectors to connect the particular wire, but that can be happened in the previous wires. We can simply make the attachment of these wires and repair that physical damage, but in this case it is not easy to maintain the physical damage. So this is all about the optical fiber cable.